Good morning, students. Hello.
Good morning, ma'am.
Yeah, good morning. So we will start. In the previous lecture, we have started with diagnostics in automotive. Okay. So what is diagnostic procedure? What are the different types of noise that we have studied? What do you mean by diagnostic trouble code? Okay, or diagnostic codes, it is called as. Okay. So the difference between OBD1 and OBD2. So these are the onboard diagnostics techniques. Okay, and the OBD1 is represented, or the fault in case of OBD1 is represented using your malfunction indicator lights. Okay, so which is also called as MIL. So MIL is used to represent the fault related to engine component, okay, engine system. So in terms of the blinking pattern with the help of MIL. Okay, so that is OBD1. Basically, OBD1 is representing the uh, fault, or it is representing the fault codes related to your engine system. OBD2, along with engine system, all other components can be taken care by OBD2. Okay, so it's an enhanced version, or the latest version of your onboard diagnostics. Okay, so where how the codes are interpreted, how the code is represented, that we have just gone through. So tables are provided already representing the code and its interpretation. So usually that code is 5-digit code. Okay, so where the first is always character representing the subsystem of your vehicle, and the detailing is represented by other 4 digits. Okay, so uh, these things we have covered, and to read these fault codes, there are various scan tools available. Okay, so various softwares available, analyzing softwares are also available. So but those softwares will be connected to your OBD2, or it will be connected to that, it need to be connected to the port which has been provided to get these trouble codes. Okay, so diagnostic trouble code DTCs can be read through the diagnostic ports which are provided in your vehicle, and through that port we can read this, we can analyze the data. Okay, so in what we can say is the real-time sensor values you can obtain by connecting such scan tool to your OBD2 port. Okay, so till this we have covered, and I think this part we are going to start with what is OBD2 OBD port. So as I said, it is also known as the SAE J1962 diagnostic connector. So wherever these numbers are coming, so that is representing standardization of your particular port, standardization of the protocols, or the things that you are using in your vehicle. Okay, so OBD2 port connector, it is also known as SAJ1962 diagnostics connector. Okay, so this is what is that connector. I'll just show you. So it has been better represented in the write-up. So this is that port is also known as diagnostics link connector. So diagnostic link connector, it is the standard 16 pin port or connector, okay, used to interface your OBD2 compliant scan tools. Okay, so this is the representation, and this particular picture is representing where exactly you can find this OBD2 ports in your vehicle. Usually this particular port is existing, you can check it. Okay, so it is existing below your steering wheel and just above the pedals. Okay, accelerator pedals. So in between pedals and the that steering wheel, you can find this port. Okay, so this is the port. So like this, you can have that port. It is usually, I think, we closed, or some in some vehicle it is open. Okay, so you can directly connect your uh, this dongle, we can say. Okay, so either you can directly connect the scan tools which are wired. Okay, and there are various components which are existing, like which will work on Bluetooth. So wirelessly you can access all the data through this connector onto a software, or on a particular scan tool related software. Okay, so either you can directly connect, or it can be connected through wire, or wirelessly we can connect this thing. So it's a 16 pin connector, and I'll show you the few pictures of that connectors. Sorry. So this is representing, usually the number is ELM 327. All these are representing various versions of ELM 327. Okay, so this is, I think it's a code reader, Bluetooth operated. So you need to connect through the Bluetooth. Okay, so this is also Bluetooth. It will be connected via your Bluetooth to the OBD2 port. Okay, there are few Wi-Fi operated OBD2 connectors are existing. Okay, and few are like through wires you can connect. Like here you can see the wire. So through cable also we can connect this particular connector, and this can be connected to your PC, where through this device, through this connector, you can get access the data. Now what data we can access through this port? Before that, we will just go for the pin configuration. So it's a 16 pin connector. Okay, so which supports various different protocols. Okay, so for example, you can see here these two green pins will support SAE J185 bus, 50 bus. Okay, whereas you can use the CAN protocol to access this trouble codes and other sensor data. You can get the live sensor data. Okay, uh, apart from this CAN operates on CAN high and CAN low. Red is representing CAN. Okay, so apart from this, it is also supporting ISO 9141K line. Okay, and apart from these various protocols, it requires the supply. Okay, signal ground, and so that is connected to ground pins. Okay, and here it is 12 volt. It operates on 12 volt supply. Okay, so this is the pin configuration through which, using one of the protocol, you can access the data like trouble codes. We can read all the engine sensor values. So where you can read these values. So this is something I have opened your last experiment. Okay, so it is representing fault diagnosis through OBD2 port, and here I have represented one, I think one or two graphs I have put in this. So this is representing the live data that has been recorded by connecting that OBD2 connector to the vehicle. Okay, and here, if it is clear, I'll just show you. This violet color is representing intake air temperature. So this blue color is representing engine RPM. So we have just started the vehicle, and these sensor values can be recorded. You can see, and the green one is representing it is representing your vehicle speed sensor. So vehicle speed as well as engine speed can be compared here. Okay, and this data can be accessed live, so we can get the current sensor values to the software. Okay, by connecting that particular connector to OBD2 port, and this is also representing the same thing. Okay, so for two different batches, whatever readings we have took, so that has been just added in this writer. Okay, so apart from this, you can export the sensor data in the CSV form. I'll show you where all these things can be obtained. Okay, so this is what is the Excel form where you can just get here, calculate the engine load, so engine coolant temperature, engine RPM, vehicle speed sensor. It is representing 0 because only engine is on. Okay, so intake air temperature and all these sensors values, whichever sensors are existing in your auto doctor. There are many softwares existing, so this is also, you can install this OBD auto doctor as an app on your mobile. Okay, and through your mobile Bluetooth you can connect this OBD to that connector to this particular app. Okay, so initially it will just this is the what we can say is the it's not the standard version, it's not it's a trial version of the software. Okay, so we will simply right now click here. When I start this, okay, when you just click on this, you will get this welcome to OBD. So we have to click on this continue, and you can find your software something like this. Okay, so here you can find the summary you will get. So engine code, so whatever is the dashboard readings, all those readings are available. Apart from that, you may get the freeze frames. Freeze frames are nothing but it is something which gives you information whenever your software or whenever there is the diagnostic trouble codes are getting saved into the memory or ECU. Okay, ECU memory. So what are the environment or the other sensor readings related to your engine? So at what condition uh, that particular trouble has been occurred. For example, there is some fault. Okay, so for that particular fault, what will be the engine temperature? What was the load condition? Okay, so what is the engine RPM? What is your vehicle speed? All this information has been stored, okay, at that particular instance whenever your trouble has been occurred. So that is represented by your freeze frames, and just getting those freeze frames and the fault occurred, we can relate these two things so that we can have the proper diagnostics of that fault. Okay, diagnosis of that particular fault. Okay, so this is a summary. You can find all those trouble codes. If any trouble codes are saved in your memory, so those can be, you can get it from this screen. Trouble codes confirmed, this diagnostic trouble codes pending means we have just access, but those are not yet solved. Okay, so permanent which cannot be rectified needs to replace the system. Okay, so freeze frames just now I have discussed. So all those readings, the trouble code and the sensor snapshot you'll get here. Okay, so those free in the form of just the sensor values, and this is what we have talked about the various trouble codes and its interpretation. Okay, B stands for body, and remaining four digits represent where exactly the fault is. You can see the complete list is available with that particular software. Okay, so this is how, where or using these softwares or your service stations, wherever you are taking your vehicle for servicing, they are using these softwares, not exactly OBD auto doctor, they might be using some other, but it works very similar to this particular software. Okay, so where they can find out what exactly is the problem, is there any problem with any of the component, and if yes, what are the trouble codes, those are saved, and those can be just diagnosed by the uh, experts. Okay, so diagnostics, as I said, here you can actually check those, or you can get those graphs. Okay, here you can see here show legends. Okay, if possible, I'll just try to make a video and I'll share that video with you. Okay, by selecting all those options and by just starting the vehicle, how the readings can be taken. Okay, so those two graphs can be obtained from this particular screen. Okay, so onboard diagnostics monitor, here you can get various sensor. Actually here there is the option to select the sensor values, okay, or a particular system related to what you want to measure the sensor values. Okay, so again this is not the full version or the standard version. As I said, uh, it is the trial mode, so many features are inactivated in this, are not active. Okay, so this is diagnostic, where we can get the engine speed and all those things, and you can export that particular thing through the extracts. Okay, so here you can see uh, the issue related, just description or information. Okay, and here it is the monitoring. So sensor graph, sensors, what sensor list it will give you. And okay, here you'll get that, sorry, in diagnostics, in monitor you can observe that all the Excel sheet or the readings related to your sensors. Okay, so this is one of the snapshot that has been taken, which is taken from the same screen, which has been exported from this particular screen. Okay, so you can select the sensor. Right now it is not connected to anywhere, so you cannot see anything. And sensor graph, we can get it from here, and in the histogram form we can get it. So you can have just live reading of your sensors is possible, and analysis of those values is possible using this OBD auto doctor or similar type of softwares. Okay, so few snapshots already included in this write-up. Okay, so this is all about your last this write-up, and we have also covered that diagnostic diagnostic link connector. Okay, so which is nothing but it's a component which is used to extract the engine related sensor, engine related data, or the sensors which are involved in the engine management system. All that value, all those sensor values can be extracted. We can get the live RPM, engine RPM, vehicle speed, and all those sensor data through that uh, OBD connector. Okay, so which is called as diagnostics link connector. Okay, so through that we can have all these readings. Okay, so this is all about your diagnostic link codes. Okay, link connector. So this is one of the example or picture is represented in this particular presentation. Okay, so is there any doubt in this? Is that clear? How the you can just search for these softwares and you can buy this particular unit. Its cost is, I think, from 500 to 700 you can get, and you can even scan or check the status of your vehicle. Okay, so the current status of your vehicle through that particular software. And the same software is used by all the service stations for diagnostics or for just checking your vehicle related data. Okay, the sensors or components related data. Any doubt? Is that clear? Yes.
Yes, ma'am.
Yes, ma'am.
So here are few examples of the scan tool that has been represented. Okay. I'll just take you through the different scan tools which are available. So we are not going in detail of those. So something like this where you can get again the graphical type of data. Okay, this Foxwell. Okay, so DCT lookup table, then Realtek data. So everything you can get that data printed. Okay, you can connect the hand tool to your printer. Okay, so this is or sort of this your scan tools or many scan tools are available. So this is another scan tool, Innova color screen with Bluetooth enabled scan tool. Okay, so here actually the software that we have just gone through is already inbuilt. Okay, and here itself you can have analysis of all those data. Okay, so here it shows you what are the things those are supported by this scan tool. Okay, ABS and all those things. Okay, so this is engine related, so this is driver safety related and all those. Okay, battery related data. So everything can be obtained and can be analyzed using these scan tools. Okay, another scan tool which is launch X431 431 pros. Okay, like this you can just go through the description and various scan tools which are available. So these are most commonly used scan tools, and here you can see how it will be connected. Actually this is, I think it's the old location, or it is the old car, I think, because nowadays you can find those connectors uh, just below, as I said, in between your steering and the pedals, accelerator, brake pedal. Okay, so there you can connect, and wirelessly I can just have that data on the laptop through various softwares like auto doctor software. Okay, so that's all about these scan tools. We are not going in detail of those scan tools, which works very similar to this particular OBD auto doctor software. Okay, so that everything is available with that particular scan tools. Okay, where it can be connected. So after that, so this is all about your DCT, DLC, MIL, mm, and what is OBD, difference between OBD and onboard diagnostics and offboard diagnostics. The difference is onboard is where you can have the live data stored and the real-time decision taken by your ECU to overcome that particular fault. And offboard is nothing but through scan tool we can analyze that particular code, so that is known as offboard diagnostics. Okay, and all these diagnostics have again based on some predefined standard rules. Okay, which are known as diagnostic protocols. So under this diagnostic protocols we are going to just go through. We have a brief description of KWP 2000 protocol and UDS protocols. We'll see these two protocols. So the first one is known as the online diagnostics protocol. That is nothing but It's the set of rules defined by this ISO and SAE. Okay, so for communication between your ECU, the ECU under diagnostics, and the tester. Okay, tester is nothing but it's the rules which are used for transferring your diagnostic codes to the PCM, or just communication between the tester and the ECU. Okay, so those rules and how this communication, how this information will be transferred. So defining those standards is nothing but your diagnostics protocol. So most commonly used protocols, as I said, is there are various protocols existing. Okay, so this OBD2 also comes under one of the can also be known as the diagnostic protocol. Okay, so which supports all these protocols, KWP 2000 as well as UDS. Okay, apart from that, we have just seen it is represented by ISO 9141, okay, or HJE 1850. So like those names are given, so that is representing the standardization. Okay, so uh, as I said, there are many like K-line, KWP, UDS, okay, and out of these, most commonly used protocols are KWP 2000, and which is also called as keyword protocol, and second one is UDS, that is Unified Diagnostic Services protocols. So these protocols, what exactly is this protocol and how what is difference between these two, that we'll just go through. So as I said, this is also called as keyword protocol, is one of the onboard diagnostic protocol which is compliant with ISO 14230 standard. So it is based on this particular ISO 14230, that is it is following the rules. Those are set by this standard 14230. It is usually represented by 14230 colon 1 dash 3, that is including all the data layers, like the 3 layers or the 2 layers, that is of OSI layer. Okay, so that is your physical link layer and data link layer. Okay, so that is taken care by this particular protocol. Okay, so it defines a common set of communication codes for exchanging data used by vehicle ECU as per the guidelines of OBD2 regulatory standards. Okay, and where these standards will find, those standards we can get it from ISO 14230. So this KWP 2000 is compatible with both K-line. K-line is representing your ISO 9141 standard, as well as it is compatible with the CAN protocol. Okay, so CAN in vehicle networking protocol, that CAN is represented by ISO 11898. Okay, now the CAN which we have studied, it works, the protocol remains same, only the thing is that here we this KWP is using this CAN protocol for communicating your diagnostics information. Okay, there we are using that CAN protocol for communication between two devices. Okay, finally we are performing communication, but here, so when to initiate that particular diagnostic signal, whether it is really a diagnostic code and it needs to be transferred, if as the data is related to which sensor, where it has to be transferred, what should be the baud rate. So defining all those things is nothing but using that KWP 2000 protocol. Okay, so it supports both, as I said, K-line as well as CAN. So K-line is nothing but so this is representing actually physical layer. So whenever there is the data transfer on the bus, so that is representing the physical layer of your protocol. Okay, so which is represented by -2. So as I said, 1 to 3, that is data link layer and your physical layer and your application layer. So that is representing 1, 2 and 3. Okay, so it uses bidirectional serial communication with the controller. So K line represents bidirectional serial communication. It also uses L line unidirectional communication to wake up the automotive ECU. So it supports both these, whereas K is actually to start the communication as well as to transfer the information, whereas your L line is unidirectional. It is only used to initialize the communication, not for actual data transfer. Okay, so it may sometimes use both L line to start the communication and K line for actual data communication. Okay, or only K is sufficient, which will perform both these operations. Okay, then the average data rate with which your KWP works is it is in between 1.2 to 10.4 kilobaud. Baud is nothing but bits per second. So it is kbps in short. Okay, and the data feeds with the message may contain up to 255 bytes. Okay, so like between your tester and the ECU, scan tool and ECU will be done. The data transfer is done through your K line. Okay. So there are various possibilities for the way in which communication is established. So this we'll discuss afterwards. The communication services are specified, but there is some freedom for customer specific application. So there is provision that customer can decide, can just has freedom to just use those, how it can use those communication services in case of your KWP, which is possible that if you might have observed, there were a few gray keys, gray connectors. Okay, I think I have just closed that one. Okay, so those are not defined for any standard. So there we have use our own programming, and through that we can make use of those connector. Okay, to get the data in the way where user wants to get interpret or just use that particular data. Okay. So this is about your KWP. The message format that has been used by this KWP, it consists of three different parts, which is known as header. Okay, so which is a maximum, the size of this header is up to 4 bytes, and data bytes, as I said, it can transfer the data up to 255 bytes, and one checksum byte is existing. Okay, so this particular first byte is represented as, that is format byte. It is the format byte. It is represented by 8 bits, where the first 2 bits are giving us the address information. Okay, it is for example, if it is 00, there is no address information. 01, it is going into the exception mode, there are some error. Okay, so if 10, it is representing address information and physical, basically physical addressing it is representing, and 11 is functional addressing, functional data. Okay, functional safety related data. Just your target address, source address, length. This is 1 byte, I think. No, yes. Okay, and then the actual data has been transferred and checksum. Okay, so you just remember that we will relate that data frame. Okay, so as just now we have seen, the header is made up of 4 bytes, out of which the first byte is represented by your format byte. Okay, so contains the information about the address information, as well as it provide the quantity of data, how much byte of data you are transferring onto that particular bus. Okay, so this represents the coding up to 63 data bytes, and if the data bytes is exceeding this one 63, so that is represented by your length byte. Okay, so which can be up to 255 bytes maximum. So from 0 to 63 is represented by these 6 bits of the format byte, whereas if the data bytes are exceeding about the 63 bytes, it is represented by length byte. So target address representing the target information where we have to send the information, and what is the source address, source component address, or source ECU and target ECU, we can just say the address of those components will be represented by this target address, source address. Length byte, as I said, if it is exceeding above 63 data bytes, it is represented by that length byte. Okay. So data bytes up to 255 bytes of payload can be sent per message. The first byte of payload is always representing service identification byte. The subsequent data bytes are the data that differ depending on the service concerned. So it is representing service identification. Identified by this particular service identification byte. And this is obviously for error checking in the data transport. So it is using 1 byte checksum is always positioned at the end of message. It contains the value of modulo 256 sum across all the messages in the frame. So the checksum is performed on all the bits starting from your header to data bytes. So it will perform modulo 256 on these bits. Whatever value is represented as 1 byte checksum. Okay. So as I said, there are two ways of communication here. Somewhere we have just gone through. Okay. So there are two possible ways of communication, or these are the two ways to initialize your communication basically. One is known as five-baud initialization, and second one is fast initialization. Okay. So 5-baud is nothing but the communication is initiated with 5 bits per second address sent by the tester. Okay. So it is possible that for each ECU to be addressed individually, and addressing is clearly separate for the data transfer. Okay. So only initialization by setting some address, 5 bits per second address. So that communication has been initiated. Okay. And based on this bit pattern, it will decide, it will interpret this bit pattern. Okay. On receiving the address, the ECU responds with the baud rate recognition pattern. Okay. For example, if this is the baud rate recognition pattern, or this is the received baud rate or the bit sequence, not baud rate. If this is the this is five-baud initialization, and for fast initialization, so it is faster than your five-baud initialization. So this initialization is done by sending a wake-up pattern, which is consisting of a low and high phase, each lasting for, or instead of phase we can say a low pulse and high pulse, each lasting for 25 milliseconds. Okay. So at the end of wake up pattern, the tester sends the start communication service at a fixed baud rate, which is 10,400 bits per second. Okay. And the ECU returns a positive reply containing a key byte. Okay. And thus, once the initialization is complete, the regular communication may start between those two components. Okay. So this is your initializing communication between the tester and ECU, or scan tool and ECU. Okay. So this is ISO 15765. It is representing diagnostics on CAN, as we have just discussed initially. So KWP 2000 also supports CAN. So that is known as Diagnostics on CAN, and is the title of standard designed to implement the diagnostic service implemented in KWP 2000. Okay. So this provides the capability of long message transfer by using transportation mechanism described by OSEK communication. So again, this is the standard which is used in automotive. Okay, it made CAN as the media for accessing emission related diagnostics. Okay, so basically for engine related data can be communicated through your CAN protocol. Okay, so that is, in practice, diagnostics must coexist with normal CAN communication. So this is about your KWP. Now, Unified Diagnostic Services. So this Unified Diagnostic Services are the protocols which are compliant with your ISO 14229. Okay, or this particular standard is also called as UDS, which is representing your off-board diagnostic system. Okay, so it is compliant with this is the higher version basically. Okay, higher version of your KWP 2000. Okay, and hence it is compliant with the 142 ISO 142303 and ISO 157653. So this is representing diagnostics communication over CAN, and this is representing the K line of your KWP 2000. Okay, the maximum size of message supported within this UDS is up to 8 bytes only. Okay, whereas here it is supporting 255 bytes. For exchanging messages exceeding 8 bytes, the UDS protocol uses this 157652, which is nothing but diagnostics over CAN. Okay, communication area network, controller area network bus. So wherever the the information exceeds this 8 byte, okay, so it will go for DO-CAN bus. Okay, so UDS diagnostics implementation is independent of underlying physical layer and is also compatible over both LEAN and CAN. So it may work with LEAN communication as well as CAN communication protocol. Okay, it is developed to unify all the diagnostic standards that existed previously to come up with a single valid set of diagnostic service for the automotive ECUs. Okay, so this has been, as I said, it is the higher version, so it is made compatible with most of the communication protocols that we are using in automotive. Okay, this has ensured that integration of UDS protocol stack reduces the additional cost for the development of other diagnostic communication applications. Okay, like here it is going for K line, L line. Okay, so UDS is using the existing protocols for communication, and which is resulting into reduction of the additional cost. Okay, so modern vehicles have diagnostic interface for off-board diagnostic, which makes it possible to connect to the computer, which is referred to as a tester, to the bus system of vehicle, and thus the message defined in UDS can be sent to the controllers, which must provide the predetermined UDS services. This makes it possible to interrogate the fault memory of the individual control unit or to update them with a new firmware. Okay, so the interpretation or meaning of this is basically through this you can directly get the data in offline mode and you can perform the diagnostics on that. Okay. This is all about your KWP and UDS. Again, that means why we have gone through this is even in diagnosis there are the standards defined, and every vehicle needs to follow those standards. Okay, So we can say UDS may be used in offline of board diagnostics. That means at the time of testing validation of your systems. So mostly UDS are used, whereas whenever on drive problems can be handled by your KWP 2000. Okay. Here few differentiating points are given. The standard with which it is compatible is represented, the numbers. Okay, the protocol dependency. So as I said, UDS is extended version. So KWP 2000 functionalities for measurement value transfer and error memory management were improved by UDS. So those functionalities are supported by KWP, but those are improved in UDS as it is representing extended version. So tester ECU communication supports a symmetrical number of requests and responses between tester and ECU, whereas this is event based as it is off board. So whenever you are connecting, then only it get activated. So it is event based and it cannot be symmetrical. Okay, as it is event driven. Okay, event triggered protocol, so it cannot have the symmetrical requests, okay, and responses. Error memory management specifies 4 services for the memory management. Okay, one is clear diagnostic information. Once read, clear that information. Read DTC by status. Read status of DTC. Okay, and read freeze frame data. Okay, so these are the 4 services which are supported by your KWP, and it specifies only 2 services, which is nothing but clear diagnostic information and read that information. As it is off mode, it can go for only reading the DTC information, and once it has been accessed, clear that information. Okay. The functions which are supported, only 3 subfunctions under read DTC can be supported or can be activated at a time, and whereas here it will support 21 subfunctions under read DTC. So those are listed in those standards. Okay. Uh, Vehicle network supported runs on several transport layers such as K-line, which is representing serial communication, or CAN, and these are using the inbuilt protocols of the vehicle, that is CAN, LAN, Ethernet transfer protocols. ECU identification contain a specific function to identify the ECUs, read ECU identification. So it is related to your addressing of that one. Does not include a separate service to identify ECU, rather this functionality is included in read data identifier itself. Okay, so read DTC information itself is containing that particular data. So this is the difference between, KWP and your UDS protocol. And with this, we have completed the complete diagnostics, or the general information related to diagnostics in the vehicle. Okay. Yes. Any doubt? And apart from that, I have also explained you this last experiment. Okay. That means just given you the overview of that. If possible, I'll just try to make one video based on that, and I'll share that video with you. If you're having any doubt, you can ask. I'll just check what are the questions based on this. You are supposed to just attempt this post-lab questions, write this post-lab question and submit it under your experiment number 8 assignment. Okay. It's related to all this OBD2, what is onboard diagnostic, phase frame, MIL and DLC. Okay. So you can find these answers in the write-up also, or you can get help of the presentations and share with you. I think I have not included explanation, but today we have just discussed in brief what is freeze frame is. Okay. Rest everything is covered. Still, if you are having any doubt, you can ask. This ends your 4 units and syllabus. I think tomorrow I'll not arrange any lecture, so there will be no lecture tomorrow. Day after tomorrow, I wanted to check your simulations physically. So I'll tell you, I'll take you in the batch of 25 students, na 13, 12. So only 13 students will be there who will share the screen and show me all those 4 implementations. Based on that, I'm going to evaluate. Okay. Any objection for that? I'll be giving you 1 day to check your simulations. I'm going to verify it physically. Okay. You need to share your screen and show me that yes, I have implemented and these are the results of it. Based on that, because it will help me to give you marks for those write-ups. Okay. Any doubt? Anything you want to know apart from whatever we have discussed? Yes, bolo. Hello. Am I audible?
Yes, ma'am, you're audible.
Yes. Okay. Apart from this, everything, anybody interested in the projects, automotive projects to work in electric vehicle? If yes, you can contact me because there is one guy who has worked with AR AI and he is ready to give projects. Basically, he is interested in MTech student, but I have requested him to take your interview. Based on that, he will select the student and he is ready for that, and he may provide you the statement for the capstone project. Okay. If anybody is interested to work in the electric vehicles, you can contact me. I'll talk to that person, and then either you can directly talk to him or through me we will start the communication. Okay. So if anybody is interested in that, you can just give your, or you can just put a message on my WhatsApp. Okay. So, okay then, if you are not having any doubts, we will stop today's lecture. Okay. And as I said, tomorrow no lecture. Day after tomorrow, I am going to check your implementations. Okay. I'll just tell you, or everybody can join, no problem. Okay. According to this list, so it is alphabetical, I think. Okay. I'll start checking your presentation. Okay. Or as per your ERP list will start 1, 2, 3, 4 as per your roll numbers in the ERP. Okay. Okay then, I'll end this meeting.